All right, so now we're going to talk about some aspects of the periodic table, in particular atomic number and mass number. And one of these is going to be really easy, and the other one may be a little more difficult. All right, so first of all, atomic number is the easy one. Atomic number is simply, let me get my marker out here. Atomic number is simply the number of protons in the atom. Okay, it's the number of protons in the atom. That's it. All right, so, and it's going to be on the periodic table, right there, right? And it always corresponds to the element. So sodium is always going to have 11 protons. If we add a proton to sodium, it's no longer sodium, it's magnesium. If we take one away, it's no longer sodium, it's neon. Okay, so that's very important to appreciate. Atomic number, super simple. It turns out to be the number of protons, and that's it. Okay, so the atomic number is equal to the number of protons, as we said. So as I said in a previous slide, the atomic number of hydrogen is 1. Every hydrogen atom has 1 proton. Atomic number of carbon is 6. Every carbon atom has 6 protons. Okay, I think you get the idea. All right, so the atomic number, more on that. No, you know, this is really repetitive. I'm just going to skip this slide. So now, when we use the term atoms, this is an important point here, okay? So when we use the term atoms, we say they're neutral. We imply that they're neutral, okay? So if it's neutral, the number of protons is equal to the number of electrons, if it's neutral, right? So an aluminum atom has 13 protons, and therefore it has 13 electrons, right? Because it's an atom. If it didn't have the same number of electrons, it would be an ion, right? Okay, so let's do a learning check on this. Pause the video and fill this out, make some notes, and come back and check yours against mine. Okay, so I'm gonna suppose that you paused it, and I'm gonna come down here and say the atomic number of nitrogen is I don't have my periodic table up. All right, so I'm gonna go here. Atomic number of nitrogen. Let's just go back here and just do this one. Atomic number of nitrogen is 7, right? See that? It's 7. Okay? And so it has 7 protons and 7 electrons. The atomic number of zinc is right here. Where is it? Right there. 30. Okay? It's 30. And so it has 30 protons and 30 electrons. The atomic number of sulfur is 16, right? 16, and so it has 16 protons and 16 electrons, right? Because they're atoms, okay? So hopefully that's easy. Now, this one's not quite so easy. The mass number, I mean, it's simple, but it's just easy to get sideways on it, okay? So the mass number represents the number of particles in the nucleus. It's the number of particles in the nucleus. So it equals to the protons plus the number of neutrons, right? And it's always a whole number because you can't have a fractional number of protons or a fractional number of neutrons, okay? So the mass of a single atom does not appear on the periodic table. The mass of a single atom does not appear on the periodic table. The mass of a mole of atoms appears, right? So that's sort of an average. So this is kind of interesting. A hydrogen atom has an atomic number of 1. It has a mass number of 1 too, believe it or not, because it only has 1 proton and 0 neutrons. Look at that, 0 neutrons. Okay, the most common atom of hydrogen has 0 neutrons. Okay, nitrogen has got its atomic number 7. Its mass number is 14. Right? Why? Well, it has 7 protons, right? Because it's atomic number 7, but it also has 7 neutrons. You see that there? All right. And it has 7 electrons because it has 7 protons, and we're talking about atoms. All right, so let's do another one. Let's just come down here to iron. Iron has an atomic number of 26. Therefore, it has 26 protons. Right? Well, its mass number for any particular atom of iron might be 58. If it's 58, that means it has 32 neutrons, right? Because that plus that is equal to that. right? That's the definition of a mass number. Mass number is equal to the number of protons plus the number of neutrons. I gave you that on a previous slide, but it's gonna require some practice, okay? Well, how many electrons does it have? Well, if it's an atom, it has 26 because it has 26 protons. All right. So, in review, the number of protons is equal to the atomic number. The mass number is the sum of the protons and the neutrons, right? And so you can see you could rearrange this equation and say, well, then the number of neutrons must be the mass number minus the atomic number, right? It's the same equation as that. All right, and then finally, the mass numbers are given for specific isotopes only, which we haven't said much about. All right, we'll say more about that later. All right, so let's do this learning check. An atom of lead has a mass number of 207. An atom of lead has a mass number of 207. Pause the video and then come back and check your answers against mine. All right, let me suppose you paused it and say that the mass number is 207. The number of protons is, this is lead, right? It's 82. The number of protons is 82, right? And we know that the protons plus the neutrons is equal to the mass number, right? So 82 plus N is equal to 207, right? You see what's going on here? 207 minus 82, 5, 125. Wow, that's a lot of neutrons. Let me just check my math. 207 minus 82 is 125. Yeah, that's it. Okay? So the answer is that its number of neutrons is equal to 125. All right, so that's an introduction to atomic number and mass number. We said something about the number of electrons as well.